Good morning, ladies and gentlemen, and welcome to PCI Membranes webinar. My name is Paolo Sudati, and I've always been working with membrane separation processes and products. So today we'll be presenting membrane technology in dairy processing from PCI. So I will start quickly with a presentation from PCI Membranes as a company. Quick tips on cross-flow membrane filtration. Explaining why to partnerize with us, because we do have some unique products and proposal. And then going deeper into details of membrane technology in dairy industry, touching dairy marketing trends. Some of the most common application for cross-flow filtration in this industry. Our experience and something about the membrane cleaning, because it's also important to get everything cleaned and membrane working back. Then presenting the opportunity to meet us at SIC, that's a dairy exhibition in Italy, close to Naples. And then our poll and Q&As. What's important is that if you you have questions, please write them in the chat, so we will answer them in the later Q&A session. So PCI has a bit long story. It's more than 15 years they're manufacturing membranes. So it started late in the 60s as a joint venture between Porter's Ltd and Atomic Energy Authority. And then late in the 80s, PCI became the standalone business, and the acronym means Patterson-Kenny International. Then there have been some split again from Thameswater, and then joining the ITT Corporation, and then split in the business with Xylem. That's one of the most famous wastewater treatment company in the world. And then today we are part of Madison Industry as a filtration group. In the filtration group, we are a small entity. Filtration group is a big. I don't know, guys. It's skipping. Sorry for that. 2 billion revenue, 7,000 employees, and what is really caring for us is to make again the word. Sorry, I have some problems. Making the world safer, healthier, and more productive. We have production site in Poland and engineering site in UK. And then these are the products we are actually manufacturing. Historically, tubular membranes for cross-flow filtration. We actualized our production with spiral 1 membrane and hollow fiber. For spiral 1 mostly for process, and hollow fiber for effluent treatment, so wastewater. What's a membrane? Really quickly, because maybe it's already well known. A membrane, also referred to a semi-permeable membrane, is a selective barrier that allows molecules and ions to pass or being stopped by the pores. The feature is that the membranes have pores, so material is passing or not, or is being rejected by this membrane. It operates a pressure that varies inversely with pore size, and can be performed in dead end or tangential cross flow. Then we'll be explaining later on. So what's the dead end filtration? Dead end filtration is when flow is applied perpendicularly to the membrane surface, and the material is collected on the surface of the filter, and so there's the formation of the cake. That the cake, and end of the day, you should replace this filter. Usually we are talking about the then filtration when we are talking and dealing with filter cartridges. Really a commodity, but also in this case useful for getting rid of small particulates, mainly before going to a finer step of filtration that could be spiral one, for example. Then instead of on the tubular point of view, that could be also not not involved the cartridge filtration, because sometimes thanks to the ability to handle high solids, the tubular membrane don't need the treatment. So the cross-flow tangential filtration, it's instead, let's talk it honestly, it's a better filtration ways, because the flow is applied tangentially to the membrane surface, and the particles are rejected continuously in a turbulent regime, preventing for the cake blocking the pores. From cross-flow membrane filtration, you got we do have one feed that is pushed into the membrane, driven by the pressure, and so you can get permeate and concentrate. Usually, permeate is the cleaner part of the stream, and concentrate is what is rich in rejected material. We are obviously in the field of liquids. So being more specific, the technologies for cross-flow membrane filtration are microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration is rejecting colloidal and particulates. Ultrafiltration is mainly rejecting macromolecules. Nanofiltration going finer on sugar and divalent ions, and then reverse osmosis that allows only water, mostly rejecting monovalent ions. Why? Why partners are happy to work with us? Because our high quality membrane give them the possibility to get high quality products, because of our support and knowledge of the process and the products. PCI has the widest range of tubular membranes on the market, talking about micro, ultra, nanofiltration, and our unique tubular reverse osmosis product that we are the only one manufacturing on the market. So it's a unique product for us. So these tubular membranes enable us a wide variety of application, suitable for high viscosity and high suspended solids liquids, as they are super resistant to clogging. And as mentioned already, there's a need of minimal pretreatment. Our product portfolio is being completed by process spiral one membranes and hollow fiber membranes for wastewater treatment. What differentiates us is also flexibility. We are quick in response, choosing the fits and configuration. So it means we can decide what's the best geometry of membranes, engineering small footprint, optimizing energy consumption, having an hybrid membrane and cost efficiency solution for our customers and partners. It's also very important for us to have an R&D approach. What does it mean? It means that we do have problem-solving mindsets and approach to the process. We have more than 10 pilot testing units. What does it mean? It means that we are keen to test, because every process has its own history, its own features, even if the product at the end of this process is the same. So we do ask mainly to our partners to share more data share ideas also, because sometimes, you know, we can develop an each application from starting from scratch without even having experience, and get it in front our customer together with us, helping each other with also obviously NDAs or agreements and any confidentially scenarios to get the right solution and let's say process that could be super custom, other than having commercial other product that we present. Yeah, what else? It's I'm really happy joining PCI Membranes because of it's already well known in the membrane market, and also because of the know-how and the presence over 50 years in the market with both industrial and municipal markets. What we do also support circular economy because having all these membrane geometries can give us the opportunity to point at maximum resource recovery, so also a sort of zero liquid discharge. Because we do environmental care, and we care about environment, we care about sustainability, and we do it like saving energy, saving water, and try to at best to use less of chemicals. Our products, starting from spiral membranes, so these are the most relevant mainly in dairy market. For dairy applications, but we do have a lot of other membranes on our website. You can find other membranes in also industrial configuration. So speaking a bit very quickly about what we do have: high rejection reverse osmosis, RO4, reverse osmosis polisher, nanofiltration, one that is 150 kilodalton, NF2 is almost 300, 500 kilodalton, and then your ultrafiltration 5K and 10K, it means kilodalton, for mainly for protein concentration. But you can find more on our website, so please visit. Going to tubular membrane products. So this is much more complicated because we're manufacturing membranes that then fit into modules. Manufacturing tubular membranes in really a wide variety of molecular weight, because molecular weight, and also pore size, because we do also manufacture membrane microfiltration membranes. So you can see with our unique product, the B1 model, we can go up to 64 bar, even if we also have a version working up to 80 bar. That's the limit of the technology. So this allows us to play and propose and have unique also processes. And here we go with the list. So it's a very long list, as you see. Different membranes. So starting from the finer membrane we do have, that's reverse osmosis AFC 99, up to our microfiltration LM02 micron. That's microfiltration. Hydrophilic, the more hydrophilic, less hydrophilic, more resistant and less resistant to solvents. And also temperatures is really important, and also the pressure is absolutely main driver for choosing the right membranes. So there's a flexibility also in choosing these membranes, thanks to the variety of them. The pH resistant modules for particular application we'll cover later, and here are the modules in which our cores fit into stainless steel, shrouds, and fiberglass. So you can easily remove only the core and keep the stainless steel housing. Different numbers of tubes for wide variety of application in food and beverage and industrial. The unique reverse osmosis module with different configuration is the B series. B series is particular. You can run it in with all the 18 tubes, sorry, in series, or 9 and 9 in parallel, or every parallel, every tube in parallel. Sorry, it's the contrary, because you change the end cap, and so the configuration of the process, it's different. So with the parallel, is for high viscosity fluids. For example, one example of a process is concentration of silica, or fire concentration of membrane plants concentrates. Also, we do have the twin entry. So as mentioned, the two 9 and 9 in series, and then again the series one for concentration of tomato juice, wine must, liquid, seaweed, and a lot of other application. Again, here we're talking about modules and diameters, different tube diameters, membrane areas, and so also again pH range, depending on the membrane that's applied and installed into the modules. And also the required cross flow. I'm not going to get into details of every model, otherwise will take a day. So please, if you do have questions, you should ask us, and we can responding in the QA, or otherwise you can reach out to us in private, so we can move forward with your process or your questions, your doubts to be clarified. As mentioned, so we do have good variety of testing products, testing units. So they are usually lab scale, small scale units, in order to give an idea what could be the qualitative and also quantitative, depending on the size of the plant, because we do have like 0.1 square meter modules, or otherwise a sort of similar to industrial scale production that will give you also, for example, not just the on-off decision on if a cutoff fits okay, it's good for a certain process, but we give also additional information about TMP and other features of the process. We usually we propose tests that can be done on site to the customer, or otherwise we can accept samples to be done internally in our facility. They actually install both tubular and spiral wound membranes. So on our testing unit, you can test both technologies. So going deeper into the technologies in dairy industry, starting from a quick outlook of the market, the membrane market is projected to grow from 16 billion to 22 billion, projected by 2027, with a growth of 6%, and the dairy protein market is projected to grow from 10 to 15 billion US dollars by 2027, with a consistent growth of 3.5. And the trends and driver for this growth are pushed by new customer demands. So customers are likely willing to have more healthy foods, and also a sort of yeah, in my mind, it's always been like thinking about the first medicine is our food, but obviously you have to practice every day, and this is what from this interesting industry you can get functional foods, like you can separate from dairy fluids like bioactive peptides that are really making you healthier because, for example, they are fighting against diabetes. And also industrial process targets, they are energy saving against evaporation, for example. Usually membrane filtration is saving more than or approx 40% of energy that's used in evaporation. And then obviously water recovery and reuse, that is one of the best resources we have in the world, and it's absolutely good to recover it. And so the gentle process is absolutely needed to gently recover these kind of valuable ingredients like peptides, proteins, minerals, and other. So milk and whey composition. So once you get milk and you want to produce cheese, you get then whey. And what we are talking about? We are talking about liquids. So mostly they are um, there's the mostly water inside. Talking about different kind of milk, but the most of the percentage it's only water, and then we are dealing with proteins, fat, minerals, sugars, lactose, and what is important for these technologies, it's the how big are those parts, are the components. So the fat globules are like 0.1, 1.5 micron. Then you are casein micelles, they are 0.02, zero 0.3 micron. Whey protein, 5 to 20 kilodalton. Lactose, 350 kilodalton. Water is only 80 kilodalton. This is just to give you an idea on how fine is the separation. We are talking mostly with membrane separation. We are talking mostly with submicronic separation. So that's why we are talking about these fine molecules. And with membranes, we're able to separate it. So some tips, maybe obvious, maybe not. Milk is the first thing we ingest, and the only thing we need for the first 6 months of our life for development and growth. And it's a complete source of all nutrients for newborn, as it contains protein, carbohydrates, fats, vitamin, mineral, and water. So it's a goldie food. Other whey tips on whey, I find it on the web, and Hippocrates said, as I'm thinking, that may your food be your medicine. And he used to prescribe whey already back in 4046 before Christ. He prescribed whey to patients, and it was beneficial for the patients. So this is the filtration spectrum with dairy components. So talking about the milk and whey. So as you see, microfiltration membrane can separate fat globules, casein micelles, and bacteria when talking about extended shelf life milk, for example. Ultrafiltration is separating and concentrating whey protein. Lactose ambivalents, they are rejected by nanofiltration membrane, and monovalent are instead rejected by reverse osmosis, allowing only water to pass. So deep outlook of the membrane technology into the dairy process. Speaking about what the product is when treated by membrane. So milk, microfiltered milk, you can apply microfiltration to raw milk and get rid of fat globules, casemin cell, and starting the milk protein fractionation. Even if the dairy industry, in the dairy industry, most common the centrifugal separation, but it's, you know, this is what can be done with membrane technologies. But obviously, after this centrifuge, you can apply ultrafiltration. So you getting skim milk that is composed by milk proteins, lactose, and ions. You applying ultrafiltration to skim milk. You can usually it can be manufactured and produced soft cheese and yogurt if you applied if you treat fermented milk, for example, or otherwise you can get rid of the lactose from skim milk and start the milk processing concentration. Ultrafiltration is applied to milk um, to concentrate milk protein in order also to achieve an higher yield in production of cheese. Then the permeate of the ultrafiltration can be treated by nanofiltration and reverse osmosis. With nanofiltration, you concentrate lactose, partially demineralized lactose, because a bit of ions are passing into the permeate of the nanofiltration, and then reverse osmosis instead of concentrates everything. So the ultrafiltration permeate can be treated by reverse osmosis, concentrated lactose and minerals, and what's coming out, it's from the permeate, it's a water with a low CD that then can be refined by a polishing step that we see later. Otherwise, you can concentrate reverse skim milk or fermented milk by reverse osmosis. So you get concentrated milk that can be stored or transport or for any other purpose you can have, and getting also water low COD from the permeate. Once the cheese is produced, you got another fluid that's whey. It's sweet liquid. If the cheese has been added with rennet or other enzymes, otherwise you can get acid whey. So whey is the liquid that you got from the production of cheese, and you can microfilter it, so you get rid of cheese fines and the last fat pink globule. So it's a separation of the biggest part, as we already talked about. And from the permeate, you can have a more refined whey protein permeate. So you can start the concentration of the protein, the whey protein, with applying the ultrafiltration membrane. That's it. It's a 5 to 10 kilodalton, up to 20 also kilodalton membrane usually. And then the permeate is formed by lactose and ions that, again, you can concentrate on nanofiltration and reverse osmosis. The nanofiltration allows you to get lactose, partially demineralized lactose, and permeate, again, it's ions, monovalent. With the reverse with the ultrafiltration permeate going to the reverse osmosis, you will get lactose concentration and also mineral concentration, and the permeate will be water with low COD to be then sent to the polisher. Otherwise, from the nanofiltration, for the microfiltration permeate, so getting the whey with its content in whey protein, lactose, and ions, you can treat this stream with nanofiltration, getting whey protein concentrates, and also lactose concentration and a bit of demineralization. Ions on the permeate to again go to the polishing. So otherwise you can concentrate the whole whey, getting everything concentrated in. That's whey, protein, lactose, and minerals. And then the reverse osmosis polisher is really important because you can recover high quality water to be reused or anyhow discharged. And in the concentrate, you get a bit of COD remover that usually is going to the wastewater treatment plant. Other interesting application in the dairy can be the brine recovery that can be done with microfiltration, tight microfiltration, or large ultrafiltration. You will get rid of the bacterial charge and then regenerating a good stream of water into the industry. We're talking about high recovery, more than 85%. And then we are also experienced with tight ultrafiltration recovery caustic CIP. So the spent solution in the dairy market that's a must. Can be optimized recovering the caustic CIP. So water, it's a really, as mentioned already, sorry, it's a really important source for our world, and we are trying to recover it in many ways. Dairy needs a lot of water, so membrane technologies is really welcome in this industry. How can a system be operated? It can be operated in a batch or in feed and bleed. The batch as a simple it's mostly a simple system, low cost, with high recovery and good average permeate. But the disadvantages are big pipes because of the big flow rate and the energy cost. It's a topic to be evaluated, and well, the tank requirements, it's another one. So instead, the feed and bleed is mostly for big systems. You can apply the feed and bleed configuration to every technologies. Is mostly for large volumes, and the advantages are that the resident time is short, so there's also high recovery, and it's a continuous production of the product that the industry is going to manufacture. Some advantages of our technology, of our membranes in dairy processing. We have seen in our test, in our experience, the molecular weight cutoff of our ultrafiltration membrane are really good and in doing their job. They have uniform pore size distribution and high porosity, high rejection of protein, and good separation between protein and lactose. And there's no retention of lactose because sometimes in spiral wound membranes, mostly there's some product is retained. That's also a point to be understood. Sometimes when, for example, manufacturing pharmaceutical ingredients, something is left in the membrane, and so it's not the ideal solution. Our membrane some of them can tolerate high temperature up to 75 C for operation both and cleaning. The tolerance of chlorine it's not that high, but it's always like this because of obvious reason. We are dealing with polymeric membranes, so we have to take care using chemicals, and also the pH has a wide range of pH going from 1 to 13. Also, we have also some models that are fully resistant for easy cleaning. PCI has been working since a very long time with a lot of customers. These are only a few and allowed references we do have. So we've been working with Fonterra, Lonely Farm, Richmond Dairies, and Lactalis, and many more we can mention here, dealing with the wide variety of applications. So spent caustic, soft cheese production, skim milk, lactose wastewater streams for CAD reduction and whey concentration. A bit of history of this application. So with our membrane, our own membrane FC99, with 99% of sodium chloride reduction, operating pH range of 1.5 to 12 with 80 degrees. We are concentrating the whey with a 5 times concentration factor, up to 25 dry matter. And what should be noted is that the higher whey concentration allowed to reduce the water volumes sent to the evaporator. So that's energy saving. For what is that skim milk concentration, we applied our ultrafiltration ES 725 ultrafiltration membrane with molecular cutoff for 25 kilodalton, operating range 1.5, 12, 80 degrees operation, and 2 to 4 times concentration. Then with our membranes, with the same membrane, we can process cheese in order to produce it. So you can get soft cheese like quark, twaroג, operating condition as similar to the other. So the range is 1.5 to 12 pH, temperature up to 80, and different the concentration factor from 5 to 7, and also flux, so from 20 to 30. The aim is to produce the correct milk composition via ultrafiltration with minimal whey drainage. We are adjusting together with our customer, as already said. Once approaching the process, we can adjust the process together with the customer in order to optimize the production. And again, same membrane, different products, cream cheese concentration, same condition, and 3 times concentration factor. And last but not least, the spent caustic cleaning recovery with our premium tight ultrafiltration membrane, 4 kilodalton, PES that's able to recover spent caustic cleaning solution and can work from 1 to 14 pH and 65 Celsius with 90% recovery. That's a huge number. So quickly talking about membrane cleaning in the dairy industry. When using membrane, mostly in dairy industry, when you do have materials and you have to treat material like fats, sugar, mineral, and bacteria, the phenomenon that happen are polarization and fouling. Polarization, it's a common reversible accumulation of material on the surface of the the membrane, and instead falling is a irreversible deposit on the membrane. So this process must be always checked and controlled. It's dependent on TMP, but not only, also on other features of the process. But TMP, one of the key features. So the transmembrane pressure must be always controlled in order not to come to the end of the membrane, in order to recover the membrane. We are working usually with Ecolab, but we maybe in the dairy industry there are a lot of supplier of other potential formulates in chemicals, because what you need end of the day to clean in the dairy, to clean fat and protein fouling, you need high pH or enzymatic with caustic soda. To clean sugars, it's just enough to have warm or hot water. Mineral, it's the case to have a low pH, and instead for removing the bacteria, it's needed high temperature water or other chemicals like hydroxyperoxide and peracetic acid. Quickly talking about the procedure. So once the membrane has done its job, the the plant should be fed with clean water, and then you can add chemicals. So going to alkaline, then rinsing, again alkaline and chlorine. So an intermediate rinse, and then acid cleaning, and a final rinse. Mind the water quality, because it's really important to have a very good quality water when doing the CIP procedures, because otherwise you could, for example, apply having a high hardened water and adding caustic soda, you can get precipitates, and it's not good for membrane because we clog. And so talking about that, we can support you with our general cleaning and sanitization guidelines that PCI can provide to you. What else? So as mentioned before, we do have a variety of products, and we can support you with other applications. And now I'm passing the ball to Nicola Prandi, that is our director, in order to continue the presentation on what other applications are possible with our products.
Sorry, I was muted. Thanks, Paolo.
No problem.
Nice to meet everybody. As Paolo mentioned, our application go beyond dairy. And being he the expert of dairy, we'll let him talk about dairy, as he has definitely more knowledge in this field than I have. Regarding other application, our membrane, being food grade approved, can be used in many food and beverage applications, like clarification, concentration of juices, can be fruit, can be vegetables, can be used in beer, wine application, and so on. Then we have more industrial separation application, like going more to the purification of water, chemical dye stuff. Again, about food and bev, concentrating also different type of proteins, extracts, flavors, and again, non-food and bev, detergents, fertilizers, and so on. And finally, we have the wastewater side, of course, with direct filtration or the traditional MBR process. So yeah, we can target a lot with membrane. Membrane is not just about dairy, it's not just about a single application. Membrane can be used for many different applications. So also, if we look then at dairy, we can go, for example, in the CIP solution recovery, it was briefly mentioned. Then we can go, of course, to the MBR and the NBR processes, because, of course, your production generates a waste stream, which needs to be treated usually before being discharged to the local sewage network or to receiving water bodies. So there is a lot of attention nowadays. So we look at production processes as an holistic picture in which we start with giving what you need for the production, so pure water or a membrane to separate different type of molecules within your production. And then finally, we take care of your byproducts with membranes to help treating these byproducts or recovering them. Depends on what is the size of your facility, what are the byproducts in question, and so on. So that's very important. I mean, that is also probably one unique selling point of tubular membrane. Tubular membrane being more tolerant to organics and to suspended solids content are really aimed and geared towards resource recovery. That is something we believe in. This is something we are basing also our strategy in placing our products because is one of the keywords that we're going towards nowadays. I mean, it's not just about, when you have a waste stream to treat it and to make it less polluting. Is wherever you can, first you should recover anything that is valuable and make sense to reuse it in the process or to find another use. I mean, there is plenty of byproducts from food production industry that can be used as animal feedstock, for example. So it's very interesting. I mean, there is a lot that can be done. And in general, I mean, membranes are really great when combined, for example, with thermal processes that you will have somewhere in your production process. Of course, we have done a Sparrow one membrane as well. I mean, dairy was planned, covered in detail by Paolo, so I'm not going to more in detail about it. Then we have water and wastewater, of course. That's one of the application of spiral membrane. We're not really into going in water desalination. I mean, we could do it, but it's not the place where we want to focus because our membranes are more for sanitary use. And finally, we have membrane for wastewater application. I was mentioning the MBR process, for example. We can do both with tubular membrane, so the external process side stream that is very interesting when you have when you need to be really compact on the footprint and you have a small to medium installation. Instead, when you have larger installation, we can go with hollow fiber. So we hollow fiber to replace, I would say, most of the hollow fiber competitors on the market. It's really a good membrane. We have a few references around Europe. And yeah, I think it's a really competitive product with minimum demand for scouring. So it can help you definitely to save both your footprint because it has a very high packing density, of course, in the limit of a submerged membrane, and then very also low scoring air demand, so it helps your OPEX on that way. Regarding our side stream membrane that are pictured here, we have we have mainly type that is for smaller application with a stainless steel module, and then for larger application we have one with a GRP vessel that you can see on the bottom, on the right bottom. And so we can help with different type of installation, and again we can just simply provide the membrane and the modules, the membrane, or we can also help you with the filtration system engineering, finding you a local partner EPC company that can help you putting the system into place. And this is both true for wastewater application, but also for the process part. And finally, we have a few things that are coming. We are developing coated membranes. So we're starting with our tubular membrane, and we're testing different type of coatings. So definitely, if you have a very, very challenging separation application, please get in contact with us, and we can test both standard membrane that we have and also coated membrane that we are developing to see what is the best solution to your specific problem. And this is a key word here, specific problem. I mean, there is not one standard solution to all problems, filtration membrane problems in the world. We need really to understand what is your challenge, and then we can find, as you already seen, we have a very wide membrane portfolio between spiral and tubular, and also hollow fiber. So we need to find the right membrane for your application. That means the right separation point, the right material, eventually coated or not. I mean, we take a holistic look to your problem. Often we also test more than one type of membrane to really find on the field what is really that you need to solve your filtration needs. Finally, we are also working in the direction of energy saving elements. This is part of our product development overall when it comes to both tubular and spiral wound membrane. So we are working on optimizing the energy consumption. We know overall nowadays energy is a big a point of attention for any company. So definitely every kilowatt hour that can be saved is really important. And last but not least, we are developing capillary membranes for wine and beer clarification. Before that, we have been mainly busy with the tank bottom recovery with our tubular membrane. So there is something more that can be done, and we are really developing our product portfolio to fill the few gaps that we have overall when it comes to food and bev. Again, we are not interested in being a player in the mainstream desalination industry. But when it comes to process industry, we are really willing to fill any gap that we have. And last but not the least, if you visit our LinkedIn page, there is a poll, and we would really love if you can spend 1 minute of your time to answer to it, because this helps us also in developing our products. I mean, of course, we presented what we have today, but our R&D department is always active. So this really helps us to better understand what are your needs and to develop the product that you really need. Because in the end, it's the customer or partners that decide what is really important and relevant to the market. And Paolo also briefly mentioned earlier about an exhibition that there will be in Italy. So if you are based in Italy, or if you want to plan a trip to Italy and have also a nice holiday in that area of Italy, which is beautiful, I strongly recommend, nearby Naples, you can meet Paolo there. Unfortunately, I will not be able to join. But yeah, it's really recommended, and it is an exhibition about the dairy industry and also about conserves. So like the usual tomato sauce and many other types of canned products. So it is I think the last occasion this year to get in touch with us. Then of course we will keep updating our LinkedIn page with our programs for next year as soon as we plan them. So yeah, you have both a link on the bottom or a fancy QR code on the top to simply follow us on LinkedIn. Probably most of you are already doing it, as you probably heard from this webinar through LinkedIn. But if you're not, please follow us, and we will definitely let you know about all our news through LinkedIn. As nowadays, this is one of the easiest way to get in touch with all of us. And finally, let's start the Q&A session. So there were a few questions. So I don't know, Emily, if you want to read some questions from the chat, and then Paul and I will do our best to answer to this question.
Thank you both for presenting the previous parts. I see there are already some very interesting questions for us. So first question is, do you have any reference on applying membranes for raw milk application instead of high speed? If yes, how much is the OpEx of the plant?
Yeah, just to add, there was a clarification asked. Thanks, Emily. That was a high-speed separation. So definitely is a different technology, and probably then Paolo can elaborate better than I do. So raw milk is something that in the past we have been mainly doing with the tubular membrane. We are also testing currently to separate with spiral membrane. Definitely with tubular membrane, as Paolo commented, we can push the content of oil, fat, in this case fat, proteins, in general organics and solids higher. So our general approach is to do a combined system where you have first a pre-concentration with spiral, and then when you hit the, let's say, the boundary application of spiral, then we start, if you need to concentrate more, of course, because it depends on your process, we push more with the tubular because they tend to fall less, but of course we know they have other drawbacks like packing density, energy consumption, and so on. So the best solution in our eyes is not to use one membrane technology to solve your problem, is to combine wherever possible. I don't know, Paolo, if you need to add anything to it.
Yeah, no, what these requested are coming more and more actual in this period. So it seems the trend is now to concentrate whole milk up to very high solid content, but we do have experience, so we can get in touch later on this webinar.
Thanks for the very good question. Please, Emily, as we still have around 5 minutes, and of course we can extend a bit. If there are any other questions, we're really happy to.
Actually, there is other interesting questions. Can you answer if we need to provide a few best features of our membranes compared to other suppliers for dairy applications? What would they be?
Paolo, do you want to take on this? What are the best features of our membrane, talking about Spiral compared to our competitors?
So yeah, well, about Spiral, we do have good quality polymer as the best supplier of this polymer for what concern RO and NF, so reverse osmosis and nanofiltration. So it's polyamide coming from one of the major supplier in the world. And for what instead concern the ultrafiltration membranes, we do have a really good response, and also the polymer itself is really well responding to the rejection of protein. Talking about ultrafiltration for concentration of proteins like 5 and 10 kilodalton membranes. So the quality it's high. It's just a matter to test.
Thanks, Paolo, for that. Definitely is a matter of testing and see if you like our membrane. The micro and ultrafiltration are in-house developed. Of course, we have many years of experience of working with polymers. So we are offering also units to test our membranes and also membrane elements that you can test. So definitely. And then on top, I mean, we believe that we are competitively priced on the market. So that's also a good point. I mean, our aim is to offer basically a very high balance between price and performance. And this is very, very important. I mean, of course, there is a quality that nobody is willing to compromise on, and that makes sense. Mm-hmm. And then given a quality that you need, we are trying to offer a very good balance between price and performance.
Thank you. One last question from Sama. So what is the lifetime of membranes in PCI membranes? How many times can be used after cleaning?
Well, the lifetime, it's a frequent question. I've seen membranes working for 6 months, and I've seen in the dairy market, I've seen membranes working for 2 years or maybe more. It depends on what's the production. So if your production is if the system is working, if the system is working with high temperatures, so squeezing the membranes, high concentrate factor, and instead if it's working with cold temperatures, and it's a matter of what the process is. So if you squeeze the membrane, you have to clean it, and to clean it, you have to clean it with harsh environment like pH, very high pH, and also very high temperatures. All these factors are oxidant and are disrupting the polymer of the membrane. So high temperatures, chemicals, any kind of chemicals, depending on the concentration, even if it's a mild one, even peracetic acid could affect the quality of the membrane. It depends. It really depends on the application. On whey application, it's just for an example. It's really common here in Italy to concentrate whey up to 3 times 50 degrees, so the membrane can last 1 to 1.5 years. But I've also seen 6 months because it's also depending on seasonal willing of the factory. The factory can can decide this month to get more concentrated whey because of a particular request from a customer, so they can squeeze at most at worst the membranes, and membrane can work really few months. It really depends on the balance, but let's talk about 1 to 2 years.
Yeah, thanks, Paolo. Basically, the lifetime of membrane depends on the specific project and the operation conditions. So it's very hard to give ballpark figures in this stage. But you can happily contact us with the specific detail of your plant or your projects, depending on which stage you are, and then we can give an estimate based on our experience. Definitely, that is possible, but we need a bit more information to give you a number that makes sense.
Sure.
Anything else, Emily?
I think we cover most of the questions. There are some other questions which we haven't answered, but we will answer later, either in the chat or by sending you an email. Since today we have limited time, but thank you very much for all the participants, and thank you, Paolo, Nicola, for your presentation. There are also some participants which have requested for a certificate. We will also surely send that to you.
Yes, yeah. Definitely.
We
will follow up with every request. Also, probably there will be still a few messages in the chat that we need to answer. So we'll take care of everybody. Thank you again for your attention from my side and also from Paolo's side.
Thank you. Get in touch with us. Bye-bye.
Have a lovely day. Bye-bye, or evening. Bye-bye.
Thank you.
Bye-bye. Thank you.